Hey folks, we have another lecture here today. This one is on word equation. Okay, to start off, I'm going to show a quick little chemical reaction here. There's water in this bowl, along with, you can see, some salt at the bottom, and of course a bunch of salt that's been dissolved in here, but some of the salt is also so much that there's a little bit left at the bottom there. I also have this battery, and in this battery, it's a 9-volt battery. It just has the end of it with some rubber bands, and the screws here basically help me take the negative and the positive end, negative end, and extend them out to the ends. So I can see the result of an electrical reaction basically occurring in at the end of these screws. Okay, let's go ahead and put these terminals in the water and see what happens. Okay, so which reaction is this? What am I observing? Well, I know that water is in here, and though I did put some salt into the bowl, the salt only acts as a mode for electricity to jump through the water. Technically, water itself does not conduct electricity, and so you always have to put a little bit of what's called an electrolyte in the water in order to conduct electricity through it. Otherwise, actually, water never will conduct any electricity. It's an insulator. Once you've put the salt in there, however, now I'm able to have electricity jump from one screw to the other screw, and the battery is discharging, and in the process, it's actually splitting the water molecule into hydrogen and oxygen gas. On the left terminal here, you can see hydrogen gas being produced from one terminal. On the other side, not much of anything being produced, but if I was to stay here for a little while and really we were able to look at this terminal, you'd be able to see some bubbles coming off of the other terminal as well, this one on this side. And what's going to come off of that side is oxygen gas. And I know this because I've done the experiment before, and though you collect a lot more gas that's hydrogen on the left side, you will collect some oxygen gas as well on the right side. And you can then light that gas on fire. And the left side, that hydrogen gas will be explosive. It's not so explosive, you get a little pop if you store it in a little test tube. And then the oxygen gas on the right side, if you light that on fire, it just makes your flame glow very bright, because pure oxygen is obviously going to be a lot more flammable than just the air that has only about 20% oxygen in it. Now, that's a pretty interesting chemical reaction. I can see this is called the electrolysis of water, and I can see the actual breaking of the water molecule by just simply putting a battery into water with a little bit of salt. Now I'd like to go ahead and write down what I did, okay? And I'll write it down as a word equation. Water decomposes into hydrogen gas and oxygen gas. That's a simple word equation. Water decomposes into hydrogen gas and oxygen gas. That word decomposes comes from the idea that water is a molecule that starts off as one thing and it actually splits into two different molecules. And you'll remember that type of chemical reaction where you have A and B in one molecule and then splitting into A and B. We call that a decomposition reaction. Okay, a decomposition reaction. I've written the abbreviation RXN for reaction just to save time. Decomposition reaction is what we're seeing here, so we use the word decomposes because that's really what's happening. Let's go ahead and write out our chemical equation. Okay, so in the chemical equation, I'm going to identify the different parts there's water decomposing into hydrogen and oxygen. You'll notice there's another component that I haven't written yet, and that's the gas part. Now, you might ask, do I have to write down gas if it's in the word equation? And the answer is yes, because hydrogen itself can be in gas, liquid, or solid form, and so can oxygen. In fact, so can even water. So it's actually important that in our chemical equation we include states of matter. Sometimes, to save time, we don't include that if all we care about is balancing, but if we're looking at a chemical equation, it's almost always an important thing to put down the state of matter of that chemical. So let's list out the different states of matter and how we label that. Okay, so including the different states of matter in our chemical equation, again, is important, and the way that we represent that, if it's a solid, we're going to draw an S in parentheses. Now, I've done the S in cursive. In fact, we're going to use cursive for all of these because though they are written in the chemical equation, they're usually written pretty small. And it is sometimes pretty easy if you put a small little letter into a chemical equation that it can look like something else. For instance, a little s can look like a 5, an L can look like a 1, or a lowercase I or something like that. Or I guess an uppercase I. And, G maybe not so confusing, but I guess some people's G's could even look like a 9. So you could usually do a regular G, but it is important that you can distinguish these from, other things, other characters that you might write in there. So let's think about how do we include this into our equation. So water is clearly in the liquid state in this reaction. So I'm going to write the L, and I've got the loop in there to make sure it's pretty clear what kind of state it's in, and that is an L, not a 1 or something. So liquid water decomposes. Obviously, it requires energy to do this reaction. Otherwise, it's not going to happen. But if I have enough energy, like in a battery, I can actually split this molecule up. And what's produced is a gas of hydrogen and a gas oxygen. So two different molecules that are in their gas state. They're not liquids, they're not solids. They come out as bubbles, hence they're gas. Though we don't include it in this equation, there's another state of matter that sometimes it gets included in chemical reactions, and that's called the aqueous state. This isn't so much of a state of matter like plasma, gas, liquid, solid, one of those 4 states of matter. In that respect, really what it means is dissolved. Dissolved in water. Okay, so if something's dissolved in water, the way that we write it down is an A and a Q, putting that in parentheses. One example of needing to do that would be if you had sodium chloride. And if I had put sodium chloride into water and then reacted with those ions that are dissolved in the water, well, it's important to note what state of matter those are when they go through that reaction. The last part is to balance the reaction, and that's actually going to change our word equation a little bit. So let's go ahead and balance it. Let's make the O's balance, and then we make the H's balance. Now it's balanced. 2 makes 2 and 1. And by the way, when I was creating all those bubbles at the one terminal and very few bubbles at the other terminal, here's a little bit of the background of why I get so many more bubbles at that one terminal, because I'm creating twice as many molecules of hydrogen as I am oxygen. Okay, so let's go ahead and update our word equation to include the balancing part. So 2 molecules of water decompose, get our grammar right there, into 2 molecules of hydrogen gas and 1 molecule of oxygen gas. So this is a completed word equation, balanced, including the balanced components, and including states of matter. And as I read through that word equation, I get the full picture of what's happened in the reaction, and the reaction down here also reflects that. But if I did it either one of these independently, I would possibly be missing some information. It's important to be able to understand both, and that's our skill that we're learning here. Okay, so let's do one other for practice here, and we're going to include this time some sketches of what's going on. Okay, so with this word equation, I have 1 molecule of nitrogen gas reacting with 3 molecules of hydrogen gas to produce or yield 2 molecules of ammonia. Before we go any further, I'd like us to learn a couple independently important molecules that you don't necessarily need to memorize every kind of molecule that can be made, but I do want you to know, recognize, and have memorized generally the molecules that are written here. First, there's water, then methane, carbon dioxide, ammonia, and then oxygen, hydrogen, and nitrogen gases. So water, methane, carbon dioxide, ammonia, oxygen and hydrogen, and nitrogen gas. All of these are key molecules that might show up in any equation I give you, and you should be able to basically see them and identify them as what they are. The one that's probably most tricky for you is going to be ammonia, though you might also need some practice recognizing methane. But CH4 and NH3, those are 2 molecules that you're going to see all the time. In fact, one of them is going to show up right here. Ammonia in this word equation is going to show up, and we need to be able to, when we see it, recognize that's what that's going to be. Okay, 1 molecule of nitrogen gas, there's that one, and 3 molecules of hydrogen gas, and then the 2 molecules of ammonia. So there's the element, the components of our equation we're going to work with. And ammonia is normally in a gas state for this reaction, though if you've ever worked with ammonia before, you know it can be a liquid, sometimes at room temperature as well, but I'll just say for this equation, we're going to keep it in a gas state. Okay, so there's our chemical equation. Now we're going to go ahead and do the sketch. Now, in the sketch, our job is to represent exactly what happened in this chemical reaction using some pictures. So for nitrogen, I'm going to use green. And when I draw the nitrogen gas molecule, I'm going to do 2 green spheres connected together because this is a molecule that's bonded. For hydrogen, I'm going to represent that using, I'll add the little plus here, using purple. For ammonia, because it's nitrogen and hydrogen combined together in 1 molecule, that's 1 nitrogen and 3 hydrogens, I'm going to draw it like this. So that's my molecule. Those are my molecules here that I'm using. Now what I have to do, because I've drawn out the reaction, I haven't quite balanced it with the number of things that are there yet. In fact, I could even count and I'd find out there's not enough atoms on the left side to match the atoms on the right side. There's 3 purples, there's 2 purples on this side, there's 1 green, and there's 2 greens on this side. So obviously that's not balanced. How do I make that balanced? Well, first I'm going to do the 3 hydrogens. 1, 2, 3. There we go. So I've got my 1 nitrogen, my 3 hydrogens, and my, well, I need to do another ammonia. And there we go. this is a balanced equation that's sketched out and based off of a word equation. Okay, and you should be able to go back and forth from chemical equation to word equation to chemical equation, and always be able to draw the sketch based off of a balanced chemical equation or word equation that has the numbers in it. So that's important and helps us understand the all the different parts of balancing chemical equations kind of in one quick glance, and we're going to practice that in today's lesson. I hope that was helpful.